blink an LED for you and show you how it's done. We're going to build up a Linux image on an SD card, get the Pi up and running and configured, and build some quick electronics in order to blink an LED. If you've used something like the Arduino before, you might be thinking that the Raspberry Pi is a bit of an overkill for what we're trying to do. And you'd be absolutely correct. However, the Raspberry Pi is actually a full-blown computer, which means that it has some things in it that allows us to do some quick scripting and has a ready-made internet connection, which we'll be using in the later episodes. But for now, let's get started. I want to first tell you a little bit about the Raspberry Pi. In 2006, a group of people in England got together and they wanted to create a computer that was cheap, small, easy to use in order to teach young students how to program. 6 years later, on February 29th, 2012, the first Raspberry Pi was released, and it sold out in minutes. Everybody wanted it. Hobbyists, students, teachers, everybody seemed to love this thing. As of today, there are two different versions. There's the Model A, which is the slightly cheaper version, and the Model B, which is a little bit more expensive and has things like 2 USB ports as well as an Ethernet connection. So if you're following along, make sure you have the Model B with you right now. So the first thing we want to do is take a look at our materials, what we're going to need for today. Obviously, a Raspberry Pi. An SD card, that's going to hold our operating system. We're going to need some way to power it, and that's going to be using a micro USB cable. You can use an actual USB port, say, from another computer. Generally, that's not enough power to power the full Raspberry Pi and all the peripherals that we want to add on later. So I definitely recommend getting a wall adapter that can supply at least 700 milliamps of current. In addition to that, we need to connect some peripherals, as this is a full computer. So we're going to need the monitor, an HDMI cable, or you can use a composite cable if you see fit. Additionally, we need a mouse and a keyboard. I actually recommend using an integrated mouse and keyboard such as this one because that only takes up one USB port. And finally, we're going to need our electronics that we're actually going to be building into the Raspberry Pi's GPIO ports. A breadboard, an LED, a 100 ohm resistor, and 2 male to female jumper wires. By the way, we sell all of these parts on the SparkFun website. Just check the link below. In order to get started, we need to install an operating system for the Raspberry Pi. This is much like installing Windows or Mac OS X on your own computer. We're going to be storing it on an SD card, which is a piece of non-volatile memory. What that means is that even when you lose power, the data is still on the card. This might be familiar to you if you've ever taken apart your computer and you've seen something like a hard drive. This is a little bit too big for what we're trying to do, so we're just going to use the smaller SD card. Keep in mind that, once again, this is great for storing documents and anything else you want to keep around, even when you lose power. To start, make sure you have your SD card plugged into your computer. Open up a browser and navigate to www.raspberrypi.org/downloads. Scroll down to where you see the image for Raspbian. Right-click on the image and select Save Link As. This will start downloading the Raspbian image for you. You'll also want to scroll up to where you see the description for Raspbian and click on the link for the Win32 Disk Imager. This will take you to SourceForge, where you can click on the link to download the Win32 Disk Imager program. Go ahead and close out of your browser and open up a Windows Explorer. Navigate to your Downloads folder, where you will see the 2 zip files. Go ahead and extract the Win32 Disk Imager, and that's just going to extract into a folder right in place. The next thing you want to do is extract the Raspbian image. And once again, just select to extract that in place. Wait a few seconds for that one to finish extracting. Now that you have both programs extracted, navigate to the Win32 Disk Imager folder, right-click on the program, and select Run as Administrator. You need to do this because you need bit access to the SD card. Otherwise, this won't work. Once the program opens, click on the folder icon and select the Wheezy Raspbian image. You'll see that because it ends in a .img. Then, under Device, make sure that is the correct drive letter for the SD card. You don't want to be accidentally writing to your hard drive. You can verify that by looking in the Windows Explorer on the left side pane. You'll see where the SD card is listed. And in this case, it's the E drive. Go ahead and click Write, and if you get a warning saying that you're about to do something really bad to your SD card, click Yes, you do want to do something really bad to your SD card. Now that we have everything downloaded, we want to hook up the Raspberry Pi. So the first thing we want to do is flip the Raspberry Pi over. You'll see a SD card holder here. Plug the SD card in like so. Then we want to connect an HDMI cable, which is connected to a monitor. That is on this side, and plug that in. That's going to allow us to see what's going on. Next, plug in your keyboard and mouse. This is a wireless receiver for both a keyboard and a mouse, so I'm just going to put that in one of the USB ports. Make sure your monitor is plugged in and on before you plug in power. Otherwise, you might not see anything on your monitor. Plug your USB cable into your power adapter. and then plug in power to the micro USB cable. And you'll see the power come on and lights start to glow. So once the Raspberry Pi goes through its boot up sequence, you're going to be presented with a configuration tool. I highly recommend expanding the file system, so all you have to do is hit enter on this one, and it's going to run through a sequence where it actually fills up the entire SD card with the operating system. Otherwise, if, for example, you're using an 8 GB card, initially it only takes up 1 GB, so there are 7 GB that you can't use on the card. However, once you run this tool, it's going to fill up the operating system to take up all 8 GB, so then you have that entire 8 GB available for your use. I do recommend changing the user password. Keep in mind that the default username is Pi, P-I, and the default password is Raspberry. Both of those are lowercase, all one word. The next thing is enable boot to desktop, and go ahead and leave that as booting the console, and I'll show you how to get into the desktop from that. Then there's the internationalization options. You can set up your time zone, set up a local time, as you please. However, I'm just going to go ahead and show you what you need to do to change the keyboard layout. Keep in mind that because the Raspberry Pi is created from the United Kingdom, that is how the keyboard is set up, as GB or Great Britain. We're going to want to set that to US. So keep your generic 105 key, hit enter, go to other. You notice how they all say UK. And I'm assuming in this case, if you're watching this, you are in the United States. If not, set it to the keyboard language that you so desire and leave it at English US. Hit enter. And leave it at default, hit enter again. No compose key, enter. Hit no to accept the defaults. You can go through and enable any of the other options that you want, such as a camera. You can put your Pi on the internet. You can overclock it as you see fit, and anything else that you want. But we've hit the most important things, so just use the right arrow key, select finish, and hit enter. Go ahead and say yes to reboot. So once it's rebooted, we're presented with a login. For the defaults, it's Pi, P-I, and the password is Raspberry, R-A-S-P-B-E-R-R-Y. Hit enter, Linux is going to log you in and present you with a console or command prompt. Just type start X, all one word, hit enter, and you'll be into the desktop. Let's build our circuit. The very first thing we want to make sure is we unplug the Raspberry Pi. So we're going to be building an LED circuit and blinking that LED. It's kind of like the hello world of embedded systems. So go ahead and put an LED down. Notice that the flat edge is facing away or towards me. Then we're going to take our 100 ohm resistor, find where the rounded edge of the LED is, and plug in the resistor into the breadboard. Notice that because the flat edge is here, we're going to have current flowing through the resistor, through the LED, and then back to ground. So we actually want to take one of our jumper wires, plug it into one of the sides of the resistor, and we want to find pin 22. So if you're looking at the Raspberry Pi, we actually want to count with pin 1 starting right here. So that's pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We want to attach the positive side of our circuit to pin 22. Next, we want to attach ground. So we want to find the same rail as the minus side of the LED, put another jumper wire in, and we want to go to pin 6. So 1, 2, 3, 4, 5, 6. And that's it for our circuit. Let's make our first program. To do this, we're going to use Python. Python was a language that was created in the early 90s by a Dutch programmer whose name was Guido van Rossum. He actually did this as a hobby, and he named it after Monty Python's Flying Circus, which was a British sketch comedy that ran between 1969 and 1974. It's a high-level language, and it has a great community backing. In addition to that, it has support on every major operating system, which is good for us. So we're just going to do a quick hello world to see how it works. Go ahead and open up the file manager, which is this icon down here. Notice you are brought into your home directory. Right-click in the file manager, say create new, blank file. Call it blinky.py. Once that creates, right-click on that and say leafpad. That'll bring it up in our text editor. First thing we want to do is import time. And this imports the time module, which lets us do things like delay the processor and keep track of certain timing elements that are important for us. The next thing we want to do is import rpi.gpio as GPIO. The good thing about the Raspberry Pi, specifically the Raspbian build for it, comes with GPIO module already installed. So all we have to do is just import the module for Python, and it allows us to communicate with the GPIO pins. We're calling as GPIO, as that just shortens the name for us. So when we use that module, we can just use GPIO rather than rpi.gpio. Then we want to assign the pin number to a variable. In this case, we're just going to assign 22, meaning the pin number 22, to the variable LED. In this line, we're calling gpio.setMode gpio.board. This is setting the mode on the board to allow us to refer to any of the GPIO pins by their pin number rather than their GPIO number. For example, GPIO number 25 is actually located on pin 22, so we want to be able to call it by pin 22. Next, we want to set up the LED pin, or pin 22, as an output. So we just call gpio.setup.led gpio.out. Whenever we set up a pin like this, we always want to set it to an initial state. So in this case, we're just going to set LED to low. So we're just calling gpio.output LED, which is the pin number, and gpio.low. That brings the voltage of pin 22 down to 0 volts, which in turn turns off the LED. Next, we're going to do a while loop, and in this case, we're going to do while true, which means run forever. If you've used any other types of programming languages before, you might be used to seeing something like curly braces enclose your while loop. Python's a little bit different. It uses indents instead of curly braces. In this case, everything indented underneath while true is actually considered part of that while statement. We want to set the LED to high, so we're going to call the same gpio.output statement, and instead use the constant gpio.high in order to set that pin to 3.3 volts. Then we want to sleep the processor for 500 milliseconds, or half of a second. And then we're going to turn off the LED. Finally sleep the processor again for another 500 milliseconds and call it good. And those will continue forever within that while loop. Now, file save, exit out of LeafPad, and bring up another terminal. We should still be in that same home working directory, and you should see blinky.py. Note that when we're dealing with GPIO pins, we have to do everything as an administrator. So make sure you include sudo first, then Python, and followed by the file name. So in this case, blinky.py. Hit enter, and you should see your LED blinking on and off. And that's it. In order to exit this program, just hit Control-C, and it forces the program to stop and exit out of that while loop.